Okay, in this tutorial, I'm going to show you a worked example of answering an exam question which uses the Pearsons statistical test. This comes from the 2011 exam, so it's quite an old exam paper, which was structured slightly different from the modern exam. But I'll also outline in what ways the old exam was different. But you might choose to actually answer these questions in advance of listening to the answers where you feel is appropriate. And if you want to do so, then please pause the video. Now, in this exam question, we are given data for 10 years from 1996 to 2007. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, beg your pardon, 12 years. And what are we given? We are told the number of tons per hectare of wheat that an area is getting at Sittingbourne. So we're told that this area of Sittingbourne, that's the yield of wheat, 8.1 in 1996. And we're also told the millimeters of rain that is falling in this area of Sittingbourne, which we're then told is also in Kent. Now, the reason for doing a statistical test is we are looking at these two variables and we're thinking they might be related, that the amount of rainfall may indeed be related to the wheat yields. We're thinking that possibly higher rainfall might explain a bigger wheat yield. So we think that's possible. We also have data, which is known as interval data. So these are values that are counted up from 0. They've nothing been done with these values. They're not being ranked. They're not ratios or percentages or frequencies. The 8.1 tons per hectare is an actual value. And if the hectare of land was not giving me any wheat, it would be 0. And that's the bottom that I could possibly get. You can't get a negative wheat yield. Likewise, you can't get negative rainfall. It's 463 millimeters of rain. So we have got the two data sets that are going to allow us to do a Pearsons test to see if there is indeed a relationship between these two. Other thing we need to consider is which of these is our independent variable. So which is going to affect which? Well, of course, clearly our independent variable or our X variable is this one here, the rainfall. And our dependent variable is the wheat yield. So the higher this, we suspect, the higher this. The first question you're always going to get asked is for a null hypothesis, and we can see here that we are indeed asked to state a null hypothesis. Now, a null hypothesis is a negative hypothesis, so what we would always start is by saying there is no. The next part of our sentence would be statistically significant. And because this is Pearson, because we're testing for correlation or relationship, we would say there is no statistically significant relationship between. And then what we need to do is pick out our two variables, our X between rainfall in Sittingbourne, Kent, and our Y variable and wheat. So our null hypothesis would be written as there is no statistically significant relationship between average rainfall in Sittingbourne and wheat yield. Okay, that would always be worth 1 mark, the formulation of a null hypothesis. And we would then be given a result. Now, in the past, in 2011, you actually asked to calculate it, but I'm not, and you're not required to do that anymore. So I'm going to go straight to giving you the result of this test, which we can see here, negative 0.16. And that is the result. So let's have a look at the question you will get. What do we have to do with that? Well, we're going to go jump straight to D here. State your result in terms of the null hypothesis. Using table 2 below, is this relation statistically significant? What reasons might there be for your result? Well, I'll break this question down and then I'll come back to this other question here in a second. Okay, so first of all, we are looking to think about the negative 0.16 in terms of our null hypothesis. Well, it is a negative number, okay, which means that this suggests there's a negative relationship. And what that really means is that as rainfall increases, the wheat yield decreases, which might be probably something we weren't expecting, okay? So we have a negative relationship. The number is also quite close to 0. It's closer to 0 than it is to negative 1. And therefore, it would suggest a weak negative relationship. And the reason I say weak, because that number is very close to 0. Had it been 0.9 or negative 0.9, then I would have said it's very close to negative 1, or if it was a positive, I would have said close to positive 1. And I would say it's a strong relationship, but it's not. So we have a weak one. Final part is to look at our table of critical values, which they will always give you. Here we are. Now, they've called them degrees of freedom here. Let's just ignore that and just think of this as critical values. We have an N of 10. We're given it by the exam board. That's fine. We don't need to question where they came with that 10. They'll only give you what they want you to use. And is our negative 0.16 larger than that? Well, first of all, let's just imagine that negative 0.16 was actually just 0.16. We'll just remove the negative for the moment. Well, it's not larger than that, and it's certainly not larger than that. So what does this actually mean? Well, it means we have to accept our null hypothesis because our result of negative 0.16 is not larger than the 95% significance level of 0.576. And that's exactly what I would write. Now, this question goes a little bit further. It actually asks us what reasons might there be for the result. So what we need to then do is start thinking about other possible reasons why there is not a relationship between rainfall and yields, because we suspected it would be. Well, we could say that actually it might be more to do with temperature variations in this area from year to year, which might be influencing the wheat yield, that possibly wheat is more responsive to temperature variations. We might say that actually the inputs that farmers are using, like chemical fertilizer, has been varying across the years, and that might be the main thing influencing the changes in wheat yield. We might suspect that they've maybe changed the drainage, or that there are geological variations that are maybe explaining these variations. We would be looking to think of 2 or 3 possible factors beyond changes in rainfall that could explain these changes in wheat in order to answer this other part of the question. So why have we not got the relationship that we suspected? Okay, so that's us looked at the null hypothesis. That's us also told about what our results mean in terms of the null hypothesis. And the final question always comes, of course, is this a suitable test? Comment on the suitability. Well, first of all, it's a suitable test because it allows us to go beyond a scatter graph. We could have used these 2 variables to create a scatter graph, which would have given us a visual relationship of that. And indeed, it would have told us whether there was a linear relationship between these 2. And it does look like there's a relatively linear normal distribution. We don't have any exceptionally high or exceptionally low values, and they are reasonably well spread, both of these data ranks. There's not numbers that are wildly different from each other. So we have a linear, normally distributed data set, which makes the Pearson a perfect test to use. It's also good because if we do have an outlier or 2, then it's the perfect test for that. It's a stronger test than the Spearman test because the Spearman test ranks outliers into simple ranks, whereas the Pearson test keeps those outliers. And we can see there are some significantly big variations. We had 2 years, for example, 2000 and 2005, which had the same wheat yield, but wildly different rainfall. So there's a significant variation between rainfall and the same wheat yield, but very different rainfall patterns. Now, in our Pearson test, we don't lose that very significant data variation from the test, which also makes it a suitable test. We have an N of 12. We have 12 years, so the test is also suitable. It does require a very base minimum of 5, but if you've got 8 or more, then it starts to become a more reliable test. You can go a little bit further and say that actually 12 is still a relatively small amount, and we'd probably be looking for at least 50 to 100 years worth of data to determine whether there really is a statistically significant relationship or not. Final thing you want to say, you always want to say this, there's 2 things. It is a test that gives us a degree of mathematical security behind what might be just a visual observation. And a visual observation would have been garnered from a scatter graph, which we would have looked at and determined whether there was a correlation or not, or relationship. Whereas this gives us actually a mathematical strength of that relationship and can determine whether that is statistically significant or not. Now, in this case, it's not statistically significant, and that's quite an important thing. It means that rainfall isn't, statistically speaking, a very large factor in influencing wheat yields. And second thing is that it allows us to test for relationship, whereas there is no other way, there's no other statistical way other than the Spearman test to actually determine whether the relationship exists mathematically or not. So a range of these points could have been brought in. You would be looking for at least 3 in this exam question, but actually you're looking for 4 or 5 points, possibly revised, because these questions can be worth up to that amount.